Welcome back to Low Stress Math with Mrs. Bono. We are on Chapter 2, Linear Equations, Lesson 3, Graphing Functions from a Table of Values. So earlier we talked about what a function is, and we decided that it was a machine that changed things. So, for instance, a washing machine. A washing machine takes dirty clothes and changes them into clean clothes. And an oven can change like cookie dough into cookies. And it's a very consistent type of machine. It always changes things the way you expect it to. So you can't expect to put cookie dough in a washing machine and get cookies. If you put cookie dough in a washing machine, you're just gonna get wet cookie dough. But we're gonna do a couple of more examples. So I want you to stop and think. What's another type of machine that you know? How about a microwave? What can a microwave do? Well, it can take corn kernels and turn it into popcorn. That's one thing a microwave can do. It heats up your food most of the time, though. What's another not food-related thing? Because it's lunchtime and I'm definitely thinking about food. So, type of machine. Oh, I know. How about a pencil sharpener? What does that do? It takes a broken pencil and changes it into a sharp pencil. Oh, sharp pencil point. Okay, what's another machine? It could be something simple. It's a little more difficult. I really would like you to think of your own example and don't use my example, but I know that's not gonna happen. So let's think about an example. Write your own example down. Come on, you can do it. I have faith in you. Write your own example down. No? All right. How about a calculator? What happens? You put in a math problem. And what does it do? It gives you a solution. So down here, my machine is the function rule. And in this case, I have the equation y equals x plus 2. But the rule is just x plus 2. So I'm going to take the x values, or sometimes it's called the input or the domain, and I'm going to put that x value into my function rule machine, and I'm going to get out a y value, or an output, or a range. There's lots of words for the same thing. So I'm going to put in the x values. I'm going to get out the y values. But I'm going to write those in red. So -4 is my x value. 0 is an x value. 1 is an x value. 4 is an x value. Those values change because x is a variable and variables vary. Vary means to change. But the rest of the rule, the rest of the function rule, plus 2 is going to remain constant. It's going to be constantly plus 2. So -4 plus 2 is -2. 0 plus 2 is +2. 1 plus 2 is 3. 4 plus 2 is 6. So I put in a number and I get out a different number because it's going to follow the function rule. All right, so is this an example of a function? Ooh, is it? How would I know? Yes, this is a function because the x values, well, let's write that down. Yes, this is a function. And now you got the important part, the explain. Because the x values and I'm just going to list them as a set. Here's my set of x values. -4, 0, 1, and 4. Those were my inputs, my x values. And because they do not repeat, this is a function. Yes, this is a function because the x values do not repeat. Put a period, Bono, make those English teachers happy. All right, so in order to be a function, it has to be a relation, a set of ordered pairs that does not repeat the x value. We're gonna do a little bit more, a lot of bit more. All right, in order to be linear, the graph has to be a straight line. In order to be linear, the graph has to be a straight line. So we call that the graph of the function. And it's a straight line. Or it could be nonlinear. And then the graph of the function is not a straight line. So when we're talking about linear and nonlinear, we're talking about the graph of the function. What does it look like on graph paper? Is it a line on graph paper? Is it not a line on graph paper? So, also, I always do this. See the word linear? If I underline the first 4 letters, I have the word line. That's going to remind me that linear means it's a straight line. It's the graph of a straight line. So let's try these problems. To make a table of values to graph each function using the domain -2, well, what's domain? I'm going to go back on the page before. The input is the domain, the x values. So I am going to input this domain in my x value. I'm just going to write domain up here to remind me. Here's my domain, -2, -1, 0, 1, and 2. Now, what's my function rule? Well, I have a function y equals 2x, but only the 2x is the function rule. So I'm going to take my x values, put them into my function rule, and I'm going to get the y values. Okay, what stays the same? The coefficient 2, that's going to stay the same. What's going to vary? The variable x. All these numbers are part of the domain or the x values, and that's what's varying. -2, -1, 0, 1, and 2. So now I just have to multiply. 2 times -2 is -4. And then it has parentheses here. This is going to, well, this is the range. The range is the y value. This is the rule, the function rule is 2x. And these are the coordinates. This is the point. I'm going to write coordinates up here. And that's always an x and a y. Well, usually an x and a y. So my x is -2, my y is 4. It's important what order you put them in. The x comes first. So -2, -4. I have a point way down there. Now I'm doing the next one. 2 times -1 is -2. My x is -1, my y is -2. And my coordinates are -1, -2, -1, -2, and I'm using my coordinates to graph my points. 2 times 0 is 0, x is 0, y is 0, my coordinates are 0, 0, and I'm going to use that to graph my next point.